you have got some data, you did it, but your accuracy is 80%. Will you be able to publish in a paper? No, right? Because with 80% will not happen anything. So you have to increase it. So for increasing, you have to understand the maths behind it. And I have seen most of the people like avoids these maths because these are actually hard to digest. So, but I will try to explain all the concepts lying under the hood. And first, if you give 100% focus, then you will understand 70% of the thing. Later on, if you go back home and you try to recapitulate the things, then you will understand like the rest 30% you will understand. So here there are 2 points. One is circular point, and another is like cross points, right? These 2 points belongs to 2 different classes. Say for example, I am considering this as class 1 class, minus 1 class. This is same. Minus 1 class is actually say no tumor or no diabetic, anything. Class 1 is having tumor. Okay. Yeah. So if you see, like we want to find a classifier. Classifier is this point. So in between, I have given a line. Here also you can see in the board there is one line which is classifying like rate, viewpoint and the grid point perfectly. Right. So it is a good classifier. Now the thing is, what is SVM? SVM is actually a powerful machine learning algorithm which uses supervised machine learning concept. Supervised, I have already mentioned, there are 2 things: supervised and unsupervised. Supervised means that we have all the images or all the signals and we have annotation for that. That is, we have label for that. If we know it is an apple, there is annotation that it is apple. If it is a banana, then there is annotation that it is a banana. But if we don't know anything, like we are randomly giving something to a model, and model will try to find some pattern. Like it will try to find out, okay, this looks like apple, this round shape looks like apple. So I will consider it as something. He doesn't know the name, but he will consider it something. If you are giving that model a banana, he knows it is elongated like shape. So he knows if something comes as an elongated, he can cluster it to that elongated basket, right? So anything which you are giving him as circular, it will say that it is a kind of apple, it is a kind of banana, without knowing the level. It might happen you are getting some images from hospitals, and the technologist may not has recorded everything. So in that way, it will become unsupervised learning because it doesn't have any data. But this algorithm will hold true only if we know the level. If we don't know the level, then it will not hold true. So that is called supervised machine learning algorithm. That is, it has the level data. Now the second thing is that it tries to find out the hyperplane. Hyperplane means some plane. If you consider it maybe say as a paper or something, some plane on 3D, that which will differentiate between these 2 classifiers, right? So it's a hyperplane which is differentiating between these 2 classifiers with a maximum marginal distance. Maximum marginal distance, what is margin? These are margin. That is the weight. While this maximum, if the thing is very close to each other, it means that there might be some chance that it is not getting classified properly. It might happen if the points are so close to each other that it might happen that these either like here or here. So it might have a chance that it is not able to classify and one point may go here in the opposite region. So it means it will not able to classify that portion. So with maximum marginal distance is very important concept. The distance would be maximum between these 2. Between these 2 means between the data points which are opposite to each other. And the nearest data points, these nearest data points which we are getting is called support vectors. Here it is mentioned between the closest points, support vectors are different classes. So we have different classes, but those points which are closest to the hyperplane is known as support vectors. Next thing is that when we are using the support vector machine, we know that, like just for an example I have given for classification, dog versus cat, tumor versus no tumor, where we can use this support vector machine. We should know where to use, which one to use. And then another is regression. Regression is like I have mentioned, like there is some X data and X data, Y data, you are plotting it, you are taking a fitting of that curve, like stock prediction. Now another key concepts, like I have mentioned this thing, like hyperplane is a decision boundary which is classifying these two defined classes. Support vectors are the vectors which is nearest to the points. Here, this point is the nearest to the hyperplane. So it is one support vector, this is another support vector. And by that it names as support vector machine. And this is the hyperplane, which is parallel to these hyperplanes are known as marginal planes. These are parallel to these things, like which is passing through the support vectors. And this SVM can be of different types. It can be of linear or maybe of non-linear types. Say here I have given an example like this is linear. This is very easy to classify, but this is not very easy because like these are non-linear structures. I will not go into non-linear things today. I will give a basic example with respect to the linear. Now there are different things like kernel types, soft margin, hard margin. I will come to these points. And this is one of the very important questions of the interviewers. Like even like I have been asked, like, and I also ask in the interview. Lots of people ask in the interview. You should know these things. Like these are very basic things. And like if you go for interview, MNC or MS, anything. Like what is the difference between SVM and logistic regression? Though we are not covering logistic regression today, but like you may note it down somewhere. So while before going for the interview, you can brush up these things. Like though both creates, like the concept is same. Both creates this hyperplane which I have shown, a plane which is separating both the planes. But the thing is that the difference between them is that logistic is a probabilistic approach, but SVM is a statistical approach. By using the statistics, we are doing it. So this is important thing. Just note it down. Later on, maybe you can go through this. Which is human perceptual model. So there are lots of neurons in our brain. So this is the input layer. Input layer means a mosquito is coming in our hand. So it is going to the cell body, that is a neuron. Same thing, there are different inputs which we are processing by checking an image, whether it is a dog or cat. So these are the different kinds of inputs which is going to our brain. Now what is brain? Brain is composed of these different types of neurons are there. These neurons are called hidden layers, because we don't know what is there inside. And then at the end, there will be an output. Why? Output is like, it will say like whether you have to slap that mosquito or not. Okay. So this is the output. But inside what is happening? Lots of information is going from one neuron to another neuron. And then it is quickly processing. So these are called weight. W1, W2, let's say W3, W70. In this way, different weight is given. What is weight? Weight is the weightage, like how much input should I take? Maybe like one brain is saying like slap it, another brain is saying like it's an animal, don't slap it, it's an ultimately living thing. Okay, so different kinds of like weightage we will be giving like information, and on the basis of that, what we will do? We will do x1 into w1. We will multiply x1 into w1 plus same way x2 into w2. X2 into W2. In this way, we will multiply all these things to Xn into Wn. Plus, there will be something B. B is some unwanted signal. Like when we are thinking, like lots of things comes in our brain, right? It is unwanted. We don't want it. Like when we try to sleep at night, lots of things comes in our brains which we don't want. Still, it comes. That is the unwanted signal B. Okay, and then we give. Finally, we have something called output. We can represent this thing as W transpose of X plus B is equals to Y. Same thing, because ultimately what does it mean? It means summation of X of I multiplied by summation of Wi into transpose plus B equals to Y. Right? This summation where I runs from 1 to n. For simplicity, I am taking this thing. And when it is a hyperplane, which is the best classifying these 2 points, then at that time hyperplane equation becomes W transpose plus B equals to 0. It's a gold standard. And this is similar to Y is equal to mx plus C, because this is straight line. Here C is 0. We don't have anything. C is 0 means mx plus 0 equals to Y. If we now have do the analogous, so mx plus 0 equals to y, which means w transpose of x plus b is 0. Right? Here b is 0. Now if we, so what is a? What is the slope of this line? The slope of this line is minus 1. This is very basic class 11 concept. Right? If the line is like this, then the slope will be 1. 45 degree, tan 45 degree is 1. Right? Tan 135 degree, you will say minus of it, then it will be minus 1. So in that way, so slope of this line is minus 1. And W transpose, we know the matrix of this thing is minus 1. Transpose means this is like this. And for P2 point, what will be the x? X will be minus 3, comma 0. This is actually dot product. Remember we did dot product? So dot product is like W1 into W2 dot of x1 into x2. x1 and x2 are these 2 points. Right? So what it will be? Minus 1 into minus 3 plus 0 into 0. So it will be plus 3. Right? Same thing now if we do for P1, W transpose x plus 0. So W transpose is same, like minus 1, 0, and x is 3, 3. So what will be the value? Minus 3. Minus 3, right? So minus 3. So from this we can say that any point which is lying below this red line will be always positive. Any point. I just taken an example of minus 3, 0. Any point if you take, because it will be minus 1. Any point below this line will be having some minus. Minus minus it will automatically make it positive. So it means any point behind this classifier will be always positive. Any point above this classifier will be always negative. So it means that anything it comes in this region will be a dog, say for example, or a tumor. Any region it will come here, that will become cat or no tumor. So the equation of these other two lines are W transpose of x plus b equals to minus 1 because this is the minus region, and W transpose plus b equals to 1 because this is in the like positive region. Now if you take this equation, like say it is passing through the point x1 and it is passing through the point x2. We are having these two equations, right? Now, if we multiply this equation 1 and equation 2 with minus 1, it will be the opposite, minus, minus, minus. So it will be x1 minus x2, W transpose, B will cancel each other, equals to 2. Right now this okay? Now, if we divide the both side, now we have to divide the both side by norm of W. Why we divide it by norm of W? Like we know the concept of the unit vector. If we divide it by norm of that thing, then the magnitude of that thing will vanish, or the direction will remain. So in that way, it will become x1 minus x2, 2 by norm of W, right? So this is actually the distance. x1 minus x2, what is this? Like if there is one point here and one point here, this distance is 2 by norm of W. Okay? Since this math might be a little hard to digest, increase these things, the more it will increase means if we take a reverse of it, if we have less of this value, then that will be better, right? So we have to decrease these things, and there are, while decreasing, there are some concepts like some regulation parameter will come. I will not go through that because it will be very hard. Like so, since you are learning for the first time, so we have to minimize this value. It's a kind of optimization function. So we have to minimize these things and we have to update some values. So here I have mentioned maximizing the distance, that is 2 by norm of W, is same as minimizing it, like norm of W by 2, with some regulation parameters. Regulation parameters are the kind of say hyperparameters. Like by that way, we have to overcome overfitting. So and these are the hyperparameters which you have to do after the model has been trained. So if you want to increase the accuracy, I have mentioned like suppose 80% is there and to make it to 90%, then there are few parameters. If you tune that parameters, tune means like you just tweak some values in that and again do the retraining, then you will find the accuracy is increasing. So